Science with Folly.
Good morning and welcome to Science with Folly. Today we're learning about acids and bases. Pretty easy topic and something you should all know about. Firstly, what are acids? Acids are something you should be quite familiar with. Well, they taste sour, they are corrosive, the strong ones are, but most importantly, acids release hydrogen ions in solution. That is the key scientific idea here. And what that means is that when you have a solid acid and you put it into a solution such as water, the acid particles dissociate, they break apart. And for example, if you've got hydrochloric acid, HCl, it breaks apart into the hydrogen ions and the chloride ions. The opposite of acids are bases. You've probably come across bases in dishwashing powder and things like that. Now, bases are acid opposites. They remove hydrogen ions from a solution. And alkalis are a special kind of base. They are bases, but they are soluble bases. And alkalis dissociate in water to release or create hydroxide ions. A common alkali that we use in the lab is sodium hydroxide. It breaks apart to release sodium ions and hydroxide ions in water. Now here are some terms that you need to know about and that people get quite confused about. Strong, weak, concentrated, and dilute. Strong in regards to acids and bases relates to how easily an acid or a base dissociates and releases its hydrogen ions or its hydroxide ions. So we say hydrochloric acid is a strong acid because it quite easily dissociates, releasing its hydrogen ions and its chloride ions. Whereas something like citric acid is quite a weak acid. Concentrated and dilute relate to how many hydrogen ions or hydroxide ions are in the solution. So we could have a concentrated solution of a strong acid, such as hydrochloric acid, or we could have a concentrated solution of a weak acid, such as citric acid. And similarly with dilute, we could have a dilute solution of hydrochloric acid or a dilute solution of a weak acid. Same goes with bases. Now, acids and bases are measured on the pH scale, and the pH scale measures the concentration of acids and bases. It is a measure of the concentration of hydrogen ions in a solution. And when we look at the pH scale, we've got to remember it's a logarithmic scale. That means that every step up is 10 times greater than the step before. On the pH scale, a substance with a pH of 7 is neutral. Any substance that has a pH less than 7 is an acid, and anything greater than 7 is a base. And the strength or concentration increases as you get away from 7. When we test for pH, there's lots of different ways we can do it. But the two ways that matter most for us are using these two indicators here, universal indicator and litmus indicator. When we use universal indicator with an acid, the universal indicator will turn red. And when we use universal indicator with a base, it will turn blue. When we use it with a neutral substance, universal indicator turns green. And there are shades in between green, red, and blue, which show how concentrated the substance is. Litmus, on the other hand, is a certain substance that if we use red litmus, it will stay red in an acid or turn blue in a base. And if we use a blue litmus, it will turn red in an acid and stay blue in a base. Universal indicator and litmus can be both as a liquid or a paper form. Next time, we'll be learning about the reactions of acids and bases. That's all for now. Cheers. Thanks for watching.
Science with Folly. Science with Folly. Science with Folly. Science with Folly.